Alright, so the next section is going to be about formalizing our area under the curve. So the idea behind estimating the area under the curve is we're using rectangles. So the basic idea here is we'll use n rectangles to approximate the area. And then once we get a formula for that, if it's possible to sum those, we're then going to take the limit. So to find exact area, we let n go to infinity. Okay, so we're going to do this part later. For right now, we're going to just get n rectangles to see if we can get an approximation to this area. So we're starting off with n rectangles between A and B. We're going to go ahead and let the rectangles be equally have equal width. Okay, so each rectangle has the same width, and so the width is going to be along the x-axis. So a typical way to describe the width is going to be with the notation delta x. Okay, so once we find our width, right, then the question is, what should the height of the rectangle be? Okay, so what should the height of the rectangle be? The height. And I think we saw in our example previously that typical choices are the height could be taken from the left endpoints, and we're going to use the notation L sub n to denote a left endpoint, or it could be a right endpoint for each interval, and so we're going to use the notation R sub n for that. Or you could get trickier. You could take the midpoint of each interval and use that for the height. So middle point would be, and so we're going to take that as m sub n. Okay, we'll have examples of each of those, but for the purposes of this example, let's start with right endpoints. Okay, so first of all, let's set up a little bit of notation. So if I'm going to break my interval up into n rectangles, the width of each rectangle will be what? Well, the length of this interval is b minus a, and so I want to divide that up into n pieces. So b minus a over n will be our width of each rectangle. And so now I'm going to label this a little bit differently. I'm going to use the book's notation here. We'll label the endpoints here. A we're going to label as x sub 0, and then we have the first endpoint here is x sub 1, and so if you actually wanted to compute x1, that would be a plus the width, so that would be a plus delta x, and then x2 would be the next point in our list. And so if you wanted to compute x2, you could. How would you compute x2? That would be a plus delta x, or a plus 2 times delta x. Okay, and then so on. X sub 3 would be a plus 3 times delta x. And so you could compute all of those, and we're going to keep going until the end here. So x sub n minus 1 will be a plus n minus 1 times b minus a over n. You don't need to remember these formulas here, but if you wanted to compute them, the most important ones are that a is equal to x sub 0 and x sub n is equal to b. And so you might notice how many data points we have here. We started with 0 and ended at x sub n. And so we actually have n plus 1 values of x here, right? Okay, and so those belong along the x-axis. So I'm calling that x0, x1, x2, and so on. And then b is x sub n. Good. All right, so that's just setting up our notation. And also, by the way, having these set up this nicely here will tell us which rectangle we're on. So rectangle I, we could say, has what endpoints? Well, we could say that rectangle 1 has endpoints x sub 0 and x sub 1. So, and then the rectangle 2 goes from x sub 1 to x sub 2, and so on. So rectangle I has endpoints x sub I minus 1 and x sub I. You can think of that as the interval on which we're working with rectangle I. So rectangle 1 again is uses the interval as its base x sub 0 to x sub 1. Rectangle 2 goes from x1 to x2, 3, x2, x3, 4, x3, okay, and so on. Good. And that goes from I equals 1 to n. All right. So now I think we've got all of our notation set up. Let's see. I think now you can see how these are going to work, right? Because this function here is f of x. Let me redraw that in the next. Let me pause and redraw my picture real quick. Okay, so I'm just zooming in to the ith rectangle from the curve that I had before. Remember that the ith rectangle is using the endpoints xi minus 1 and xi. Good. Now, what would the area of the rectangle be? Well, it's base times height. Right, our base is going to be the change in x, and so our notation was just delta x for the base, and so our base is delta x. And now what will the height be? And this is where it depends on whether we're using left endpoints, right endpoints, or middle points. So let's go ahead and just do each one in turn. I said we were going to do right endpoints, but we'll do that in turn. How about left endpoints first? So that would mean you're using that point to measure the height. That's your left. And so the height here is going to be f of xi minus 1. Okay, so the area of the ith rectangle is going to be, I'm going to reverse these, f of xi minus 1 times delta x. Okay, so that's the height times the width of the ith rectangle. Good. Therefore, if you sum all these together, what do you get? You would have the sum, the total estimate is the sum k equals 1 to n of f of x sub k minus 1 times delta x. Okay, so this is just summing through your n rectangles, right? And so this is a left estimate using n rectangles. So you could imagine, right, putting in, n equals 10, n equals 50, n equals 100, and summing this all together. Good. Now, let's do right endpoints instead. In that case, the total estimate would be, let's see, my right endpoint is xi, so that height would be f of xi. And so if I'm using right endpoints, I'm going to be taking k equals 1 to n. By the way, notice that when you start here, the starting x value here is x sub 0, and then you work up your way to when k equals n is x n minus 1. These are the points that you're using on the interval. But this one's going to be a little bit different. This is going to be f of xi, now xk, times delta x. Okay, so this one is using which points on the x-axis? x1, x2, up to x sub n. Okay, so that's the big difference here. And so this is going to be using right endpoints. And then how would you get midpoints? Well, the midpoint between xi and xi, or xi minus 1 and xi would be xi minus 1 plus xi divided by 2. And so here then, for the midpoint formula, you could write it just straight down here. This is going to be going from k equals 1 to n. This is telling me which rectangle I'm on. And then I evaluate the function based at my midpoint. And then I multiply by my width. Good. So this is m sub n. Good. So these are the three formulas that are estimating the area under a curve using n rectangles, and then either left endpoints for the height, right endpoints for the height, or middle points for the height. Good. And theoretically, it does not matter which one you use. They should all come up with the same answer. In the end, when we take, remember, this is just an estimate using n rectangles. We're going to take n to infinity, and in that case, all of these estimates should converge to the same number. So that's why it's not going to matter which one we use. Good. These are all called Riemann sums. Riemann is German, so we got the IE there. Riemann sums. All right. So in the next video, we'll try a couple of examples.